Hi everyone. The next lab we're going to do is over atomic structure. This lab will cover things like physical properties of the elements, their categorization in terms of families, subatomic particles, things like protons, neutrons, electrons, and then lastly we'll talk about isotopes. So the first thing you'll see when you come to the blackboard, your lab experiment sheet, your report sheet which you'll turn into me, and then a place to turn that in. Okay, below that you'll see some videos that will help you with the various sections of the lab report. Okay, so firstly, let's jump into our experiment sheet, and let's look at some of the different sections. And so what I want to do here is just to sort of hop back and forth between the experiment sheet and your actual report sheet, and just go over a few things that I think might be important to help you move along with the lab report. So the first section, we have physical properties of the elements. And these are things like its luster, is it shiny or is it dull? Is it a good conductor of electricity and heat? Is it ductile, which means can it be drawn into a wire? So we know that metals are very good at that. Is it malleable, which means can it be molded into a shape? Can I bend and fold it? And then some metals such as sodium, calcium react with air, and just various things like that would be the physical properties of the elements. Okay, so if we hop over to our report sheet, we see various names of some elements and then some blanks. And the blanks ask us for things like their chemical symbol, their color, their luster, and then are they a metal or are they a non-metal. And some of these you'll be very familiar with. Like we're all familiar with aluminum. We've all used aluminum cans. We've all seen things like maybe aluminum roofs or aluminum siding. Okay, but if we weren't so sure, if we jump back to our experiment sheet, and we come down a little bit, we'll see some photos of these elements. So here's a photo of aluminum. Okay, so we all probably could have pictured aluminum in our head, but now we have an actual photo of it. So we can get its symbol, and we can answer the questions about its properties. Okay, so if we come back to our report sheet, see the first one, aluminum, we'll give its symbol, and then we'll describe its color. So to describe color, just do the best you can. So you could say silver, black, things like that, red, copper. You could even say orange or gray. Okay, so for aluminum, I would say maybe silver. And then for luster, so I'll actually fill these in so you can follow along. And maybe for color, I would say silver. Okay, and then luster, I would say that it's shiny. Okay, then is it a metal or non-metal? Well, I know it's a metal. Okay, and then just go down the list, and you'll see photos for each of the elements. So the next one would be carbon. So I could say that it's, letter C, maybe it's black, it's dull colored, and like that. Okay, so just go through the various elements that it asks you about, and just complete this table. Okay, so let's hop back over to our element sheet and go back up. Okay, the next section is just about the periodic table in general. Okay, so I'll let you read the text form of this, but I'll go over the actual periodic table with you. Okay, so what you see is a color-coded version of the periodic table. Okay, so first thing you'll see on the left, going from the left to the right, is you'll see the alkali metals. Okay, then next to that you'll see the alkaline earth metals. And in the purple we see the transition metals. In the pink we just have what we call the metals, or other metals sometimes we call them. Then in sort of the salmon color, we have other nonmetals or just nonmetals. Okay, then in the green we have halogens, and the white we have noble gases. Now below our periodic table, in the yellow, we have rare earth elements. And what we call these is the lanthanides and the actinides. So in the yellow are the lanthanides, and that's because they start with the element lanthanoid. Then below that we have the actinides. I'm sorry, this is lanthanum. I said that wrong for some reason. La is lanthanum, and then AC is actinum. Okay, so you have your lanthanides and your actinides, and those are come down below. So just remember, these two rows fit here. Okay, but the reason they're categorized like this, you'll find out later, but the main reason is that if we remove these, then these families or these columns have very similar properties moving top to bottom. Okay, but if we put them in, it sort of causes some variation in those properties. But if we do it like this, they line up well. Okay, and so what this section will ask you to do, so let's scroll down to that section. I'm sorry, we're on B, aren't we? Okay, so we'll stay on this section. And so here, it's going to ask us the atomic number, and then it will ask us to categorize it. So here we have aluminum. Okay, so let's find aluminum on our periodic table. So aluminum is here. So I see its atomic number is 13, so I will just write 13. And now I want to know, is it an alkali metal, alkaline earth metal, transition metal, metal, non-metal, halogen, or noble gas? Okay, so I see it's in the pink color, which just tells me that it's a metal. You don't have to write other metal, you can just say metal. Okay, and that would be my answer. And then just move on down through all the elements that it asks you for, like carbon, copper, etc. Okay, and then down below that, it's going to ask us some more questions. So it's going to ask us to categorize things as either metal or non-metal. Okay, so remember, you can kind of, on this periodic table, they've been nice and they've given you this zigzag line. Okay, so everything on the left side is the metals, and everything on the right hand side is the non-metals. Okay, so all you have to do is find the element on the periodic table and tell whether it's a metal or non-metal. Okay, the next one, I want you to do the same thing, but it wants you to give the name, sorry, actually something different. It asks you to give the name of each of the following elements. So it says the noble gas in period 2. So how do you find this? So you have to, let me get rid of some of this for us. So here it asks us for the noble gas in period 2. Okay, what is period 2? So if you see to the right hand side, you'll see them labeled as period, and then you'll see period 1, period 2, period 3. Okay, so those are your periods. And just for future reference, top to bottom can either be called a group or a column. So columns, you can remember this way, is that columns hold the building up, so they have to go from top to bottom. Periods move across horizontally. Okay, and they're numbered from top to bottom. Okay, so if I want to know the halogen in period 2, I would first find the halogens. I would find period 1, period 2. Okay, there we go. So it would be neon. Okay, so that's how you answer those questions. Okay, so let's hop back over to our experiment sheet. And this next section will be over the subatomic particles. Okay, so you can probably see that you're using the periodic table a lot with this. Okay, so here we're going to be talking about things like the number of electrons, the number of protons, the number of neutrons. And one very important thing to know about the periodic table is that the atomic number is equal to the number of protons. The mass number is equal to the sum of the number of protons and neutrons. And remember that for a neutral element, the number of protons is also equal to the number of electrons. Okay, so with that information combined with the periodic table, so let's go back up to our periodic table, we can complete this chart. Okay, so let's take a look at the chart. So the first one, it asks us for iron. Okay, and it gives us the information that it has 30 neutrons. Okay, so let's go back to our periodic table and see what it says. So we'll find iron. Okay, so atomic number 26. So what did we just say about the atomic number? That's equal to the number of protons. And again, the mass number is equal to the number of protons plus the number of neutrons. Okay, so our atomic number is just this number we find in the top left-hand corner of this periodic table. So we know our atomic number would be 26. And that also means that we know the atomic number of protons, the atomic number is equal to the number of protons, so that's also 26. And we said before the number of electrons is equal to the number of protons as long as it's neutral. Okay, so this would also be 26. We have one column left, mass number. So the mass number will be equal to number of protons, so the number of protons, which will, my lettering's jumping around. Number of protons, so P plus N. That's kind of acting funny. But hopefully you can understand what I'm saying. So number of protons plus the number of neutrons. So in this case, it would be equal to 56. 30 plus 26. Okay, so just go through like this, and hopefully we can figure out what all of these things are. So given the information, so if you have to make kind of some assumptions here. So if the only information I'm given that's considered to be maybe concrete is number of electrons, then I have to assume that's the number of electrons equal to the number of protons. So like for 13, I would come to find atomic number 13. Okay, but if I know the number of protons, well, for these you should be okay doing it that way. Okay. And you'll have various information, so the mass number, the element name. So here, given the element name, I can find the atomic number, which tells me the number of protons, number of electrons, and then since I have the mass number, I can find the number of neutrons. Okay, so just go through the table like that and try to piece together the puzzle based on the information you're given. Okay, so that's C. And then lastly, D. Okay, so D is isotopes. And I wanted to go over this one with a little more depth, because this is something that you might not have ever seen before. Okay, so the first thing here, let's start with a definition. Okay, so isotopes. What is an isotope? Okay, I'm actually going to shift over to my notebook program here and just do this way so I can go nice and slow. Okay, so let's define isotope first. So isotope, let me grab a pencil. So what is an isotope? Okay, so this is just an element, or let's say an atom. So an atom that has same number of protons, but a different number of neutrons for, sorry, my F's are not coming out for some reason. A given. Okay, so this is just an off-the-cuff definition, but it's an atom that has the same number of protons but a different number of neutrons for a given element. So it has to have the same number of protons to still be that element. If I have a different number of protons in an atom, then it's no longer the element that it was before. But I can change the number of neutrons, okay, without changing the actual element. I can also change the number of electrons. That gives us ions. So just like if I change the number of electrons, that gives us ions. If I change the number of neutrons, that gives us an isotope. Okay, and we usually represent isotopes in this way. Okay, so we have A being our atomic number, Z being our mass number. Sorry, I actually gave those backwards. Okay, so A will be our mass number, Z will be our atomic number. Yeah, okay. Just wanted to make sure that I use the standard symbols. Doesn't really matter, but I wanted to make sure I use the standard symbols. Okay, so Z, this will be our atomic number. And this tells us the number of protons. Okay, A, this will be our mass number. And this tells me number of protons plus number of neutrons. Okay, so it's just the protons plus the neutrons. And if I had a charge on the element, that would be given here. Okay, so if it was, for instance, a +1 version of the element or a -1, something like that, you would see that in that corner. If there's no charge given, you can assume Z, so Z is number of protons, can also assume that's equal to the number of electrons, where E negative is just a symbol for the electrons. Okay, so now, how do we use this? So what is that good for? Well, the main thing that this is good for is, so it's good for reading isotope symbols. Okay, so what if I have something like this? So we've all heard of carbon dating, right? So you've heard of carbon-14 dating, probably. So let's write out some isotope symbols for carbon. So we have carbon. Let's just say that we have carbon 12. I'm sorry, I did that backwards. Carbon 12, atomic number 6. Carbon 13, still atomic number 6. And here we have carbon 14. This is the one used for dating, which is carbon number 6. Still carbon 6. Okay? So carbon 12, carbon 13, carbon 14. So notice what's similar to all of these. So the first thing that's similar is the number of protons is all equal to 6. If it wasn't all equal to 6, then these couldn't still be carbon anymore. They would be something else. Okay, so I think that's very important to understand. If it's not carbon, if it doesn't have 6 protons, it's not carbon anymore. It's some other element. Okay, so but what is different between them? So I said up above that the difference between isotopes is the number of neutrons. Okay, so let's see if that's true. So remember, our Z, so our top number, or A, I'm sorry, our top number, is the mass number, which is equal to the number of protons plus the number of neutrons. So let's take a look at carbon 12. Okay, so let's say carbon 12. Okay, so it's A is equal to 12, which means, if we break that down, that means that it has 6 protons plus 6 neutrons for a total of 12. If I look at carbon 13, okay, so it's A is equal to 13. So that means that it still has 6 protons, remember, because it has to have 6 protons if it's still carbon, but it must have one more neutron to make it carbon 13. So that would be 7 neutrons. Next we have carbon 14. Okay, A equal to 14, which means, again, still 6 protons, but now it must have 8 neutrons to be equal to 14. Okay, so notice the difference between all these. Let's undo that. That did not look very good. The difference between all of these is the number of neutrons. Okay, so they're all the same element, but they vary by the number of neutrons. And if I wanted to write out the number of electrons, this would have 6 electrons, 6 electrons, 6 electrons. So generally speaking, when you're talking about isotopes, you're not going to have different number of electrons. Always going to have the same number of protons, but you're just looking to have a different number of neutrons. Okay, so let's go back to our report sheet, and let's look at what they actually want us to do. Okay, so looking back at your experiment sheet just for a moment, you see all that information pretty much written out here again, just in case you want to see it again. But hopping back over to our experiment, or our report sheet here, we have another table, and they want us to fill this in. Okay, so they're giving us some isotope symbols, and they're asking us to find the number of protons, neutrons, and electrons. Okay, so we know the number of protons right away, so here let's do calcium together. So right away we know my atomic number is 12, so my number of protons will be 20. Number of neutrons, you want to take the difference between the mass number and the number of protons. So here I would just say 40 minus 20, which of course gives me 20. So this is just the normal isotope of calcium. The number of electrons I know will be equal to the number of protons since I don't have a charge. So a number of electrons is 20. Okay, so go through and you can fill all this chart in. So in this next one they tell us, oh, we still have atomic number 20, but now I have 20 neutrons. So you'll have to kind of work backwards with that. Okay, but hopefully now that you know what the chemical symbols mean, you'll be able to find those. Okay, so I think that is pretty much everything I wanted to go over with you. Good luck with the experiment. If you do have any trouble, please come see me in my office hours or shoot me an email, and I'll do my best to answer them.